Application programming interfaces, or APIs, have become the backbone of modern software development. They act as intermediaries, allowing different applications to communicate and share data seamlessly. This interconnectedness has revolutionized the way we build and interact with technology. APIs have become essential for everything from web and mobile applications to enterprise software and cloud services. At the forefront of this API revolution are generative APIs, a new breed of intelligent interfaces that leverage artificial intelligence to generate new content and automate complex tasks. Imagine an API that can create realistic images from text descriptions, translate languages on the fly, or even write different kinds of creative content. This is the power of generative APIs. They are transforming industries by enabling developers to build innovative applications that were once considered the realm of science fiction. This guide will delve into the world of generative APIs, providing a comprehensive understanding of their capabilities and how to master their use. We will explore the fundamentals of APIs, the importance of programming languages like Python and JavaScript, and the essentials of backend development. Whether you are a seasoned developer or just starting your journey, this guide will equip you with the knowledge and tools to harness the power of generative APIs and unlock a world of possibilities. APIs are sets of rules and specifications that allow different software systems to communicate with each other. Think of an API as a waiter in a restaurant. You, the diner, represent the application that wants to access data or functionality. The menu is the API, outlining the available options. The kitchen, where the actual work happens, represents the backend system that holds the data or performs the requested actions. The waiter, the API, takes your order, relays it to the kitchen, and brings back your food. APIs come in different types, each serving a specific purpose. Open APIs, also known as public APIs, are publicly available for use by any developer or company. They are often used to access data or services from third-party providers. Partner APIs are privately shared between two or more organizations, facilitating seamless integration and data exchange. Internal APIs, as the name suggests, are used within an organization to connect different internal systems and streamline operations. Understanding these fundamental concepts is crucial for navigating the world of APIs. By defining clear rules and specifications, APIs enable developers to build interconnected systems that can share data and functionality effortlessly. This interoperability has been a driving force behind the explosion of software innovation in recent years. Programming languages are the tools that developers use to interact with APIs and build applications. Two of the most popular and versatile languages in the realm of API development are Python and JavaScript. Python, known for its readability and extensive libraries, is an excellent choice for backend development and working with data-intensive APIs. This simple Python code snippet demonstrates how to use the requests library to make a GET request to an API endpoint and retrieve data in JSON format. JavaScript, on the other hand, reigns supreme in front-end web development and is increasingly used for back-end development using frameworks like Node.js. This JavaScript code snippet achieves the same result as the Python example, highlighting the language's versatility in handling API requests. Both Python and JavaScript offer a rich ecosystem of libraries, frameworks, and tools that streamline API development, making them indispensable for developers of all levels. Backend development forms the foundation upon which robust and scalable APIs are built. It involves designing and implementing the server-side logic that processes API requests, interacts with databases, and delivers responses. A typical backend system consists of a server, a database, and the application logic that ties everything together. The server acts as the communication hub, receiving requests from client applications and routing them to the appropriate parts of the backend. The database stores the data that the API interacts with, whether it's customer information, product catalogs, or sensor readings. The application logic, often written in languages like Python, JavaScript, or Java, handles the processing of requests, retrieving and manipulating data, and formatting responses. Choosing the right backend technologies and architecture is crucial for ensuring the performance, scalability, and reliability of your API. Understanding concepts like databases, server-side programming, and security is essential for building a solid backend that can handle the demands of modern applications. Section 5. API Design and Security. Designing well-structured and secure APIs is paramount for their usability and overall success. Key principles of good API design include using clear and concise naming conventions, adopting a consistent structure for requests and responses, and providing comprehensive documentation. Security is non-negotiable in API development, as exposed endpoints can be vulnerable to attacks. Implementing robust authentication and authorization mechanisms is crucial for protecting sensitive data and ensuring that only authorized users can access the API. Common authentication methods include API keys, OAuth, and JSON Web Tokens, or JWT. API keys are unique identifiers assigned to each client application, allowing the server to verify their identity. OAuth provides a more secure and standardized way to grant third-party applications limited access to user data without sharing their passwords. JWT is a compact and self-contained way to securely transmit information between parties as a JSON object. By adhering to best practices in API design and security, developers can create user-friendly, robust, and secure interfaces that foster trust and encourage wider adoption. Section 6. Generative APIs and their applications. Generative APIs represent a paradigm shift in software development, empowering developers to create applications that can generate new content and automate complex tasks. These APIs leverage the power of artificial intelligence and machine learning to analyze patterns, learn from data, and generate novel outputs. One of the most prominent examples of generative APIs is OpenAI's GPT, or Generative Pre-trained Transformer, family of language models. GPT-3, the third iteration of this groundbreaking technology, can generate human-quality text, translate languages, write different kinds of creative content, and answer your questions in an informative way. Another remarkable example is DALL, also developed by OpenAI, which can create realistic images and art from text descriptions. These are just a glimpse of the transformative potential of generative APIs. From generating personalized marketing copy and automating content creation to developing intelligent chatbots and powering virtual assistants, generative APIs are poised to revolutionize numerous industries. Section 7. API Styles and Use Cases. API styles, also known as architectures, define the structure and communication protocols used by APIs. Different API styles cater to specific use cases and offer distinct advantages. REST, or Representational State Transfer, is the most popular API style, widely used for web services. REST APIs leverage HTTP methods like GET, POST, PUT, and DELETE to perform operations on resources, identified by unique URLs. GraphQL, developed by Facebook, provides a more flexible and efficient approach to data fetching. It allows clients to request specific data they need, reducing overfetching and improving performance. SOAP, or Simple Object Access Protocol, is a more verbose and structured API style often used in enterprise applications. SOAP APIs rely on XML for message formatting and typically use more bandwidth compared to REST or GraphQL. Choosing the right API style depends on the specific requirements of the project, considering factors such as data complexity, performance needs, and security considerations. Section 8. Emerging Trends and Future Outlook. The world of APIs is constantly evolving, with new trends and technologies emerging to shape the future of software development. Serverless computing, microservices architecture, and the rise of API marketplaces are just a few examples of the exciting developments in the API landscape. Serverless computing allows developers to run code without provisioning or managing servers, reducing costs and increasing scalability. Microservices architecture breaks down applications into smaller independent services that communicate via APIs, enhancing flexibility and resilience. API marketplaces provide centralized platforms for developers to discover, share, and monetize APIs, fostering collaboration and innovation. The future of API development is bright, driven by the increasing adoption of cloud computing, the proliferation of mobile devices, and the relentless pace of technological innovation. As we move toward a more interconnected world, APIs will continue to play a pivotal role in shaping how we interact with technology and build the next generation of software applications.